Hello and welcome everyone to another Corona for Cinema 4D tutorial. In this video, we'll be tackling the new caustic solver that got introduced in Corona 4. We'll go over the basics in explaining what caustics actually are, and then the idea is to gradually up the tempo that goes from explaining how to enable caustics to how to optimize your typical production scenes for additional rendering speed. It's a fun one, so let's go at it. Alright. So let's start by talking about what caustics actually are. Now typically when we're talking about CG caustics, that's computer generated caustics, we mean effects like these. The caustics that generate the rainbow, the reflective car rim caustics, and the most common arc-vis caustics ever, the refractive glass caustics. Now there is an important distinction to be made here, and that is that for performance reasons, the caustics in most, if not all, the render engines out there are a separated effect. You see, in real life, like in this rainbow example, caustics are a part of every light transport ray, and it's only in CG where we've actually split that off into its own separate effect. So in all of these images we've just shown, all photographs by the way, if we'd essentially disable real-life caustics, we disable most of what we see. In the rainbow example, the rainbow would disappear, the sky would lose its color, the spectacles inside your cameras would not be possible, and you wouldn't even be able to focus your eyes. So you see, caustics are extremely common in real life and essential to how light works. In CG, however, to preserve rendering speed, caustic effects like the ones you see before you now are split into its own effect and calculations. Another important distinction to be made is that we have both reflective caustics, like the ones in this car rim photo, as well as the refractive caustics, like the ones that are created when light passes through an object. Both are equally important if you've set out to recreate a real-world scenario. Right on. So we've now defined what caustics are, and I think this is a great time to open up Cinema 4D and start talking about the caustics workflow in Corona. So in front of us, you'll see that we have the simplest scene. A glass, a plant, and a simple Corona rectangle light. Nothing fancy at all, just a super simple setup. Now this is the current image that we've rendered. It is rendered without the caustics being enabled, as can be seen by the apparent lack of shadows and other elements on the left of the glass here. So, let's enable caustics. In Corona, enabling caustics is really extremely straightforward. First off, we need to go into the Render Settings menu, under Corona, and Performance Settings. Down here, we have the Fast Caustics Solver, and we need to tick Enable. Right, just by doing that, at this stage, we've already set the ground up for all of the caustic effects. But do note, right now we'll only be getting reflective caustics in our scene. To enable refractive caustics as well, well then we need to go into our glass material. So let me minimize this and open up my glass material here. And under refraction, we need to enable caustics slow. Now what we've done is we've enabled the refraction caustics for this particular material. Both reflective and refractive caustics are driven by the Fast Caustics Solver that we've set up in the render settings here. But do note that for refractive caustics, you'll need to enable them in the material settings as well. Right, so now let's start this render, and once it's done, we'll compare the two images. So here they are, and wow, what a difference, huh? The image looks much more realistic and it behaves like it would in real life. Caustics really are a fun effect, and in Corona they're really easy to work with. That being said, take a look at the render statistics for the two images. While the new caustic solver is obviously more accurate and is considered to be fast, there will still be a noticeable speed hit that you just can't get away with. Caustics look good, but they need time to converge. Remember that. Okay, so another typical example of caustics can be seen in this pool scene. The scene is really basic, just a pool that's being lit with an HDRI. Right now, if I bring up the VFB, the pool looks fairly basic and dare I say a bit uninteresting. We have no caustic effects in the scene right now, but let's quickly change that, shall we? I'm going to minimize the VFB, go under the render settings, Corona, performance settings, and then I'm going to enable the new Fast Caustics Solver. Then I'll also need to enable the refractive caustics for my water material, because right now we're not getting any refractive caustics. So I'm going to open up my water material. Under refraction, I'm going to take caustics slow. And now if we just wait for the VFB to refresh here, just give it a couple of seconds, and there we go. We have these really nice caustics coming in. Right on. So take a look at this. I'm going to compare A and B with the previous, without the Fast Caustics Solver image, and the current one. So take a look at this difference. Such a drastic difference, and we only toggle a couple of buttons here. Pretty amazing, if you ask me. Alright, let's quickly jump to another scene. Here you'll see we have the scar rim and a simple light setup. Now, one of the lights, the top light here, is just a small light, but it has a directionality setting of 100%. This light is going to help us drive our reflective caustics. It's going to emphasize them a little bit more. Now, the only other light in the scene is this one, which is called the slightly bigger light, and it has a directionality setting of 60%, and this one is sort of that helper light that kind of illuminates the scene a little bit more than the other light. Now, let's bring up the VFB, where I already have an image rendered, and this one is without the Fast Caustics Solver. It actually looks pretty nice. We even have some nice bounce illumination going from the rim here and hitting the floor. This is not bad at all, but let's enable the new Caustic Solver and let's see how that will look like. So I'm going to minimize the VFB. I'm going to go into the render settings, make sure I'm under the Corona again, performance settings, and that the Fast Caustic Solver is enabled. Alright, with that done, we're now essentially ready to re-render. Now remember, we don't have any refractive materials in the scene. We're purely looking at reflective caustics in a super simple scene. Alright? So, I've actually, to save some time, already rendered the image with the Fast Caustics Solver, and I have it ready to A and B compare here. So let's take a look at the difference here. Alright, as you can see, there's a huge difference here. Now, obviously, the new Fast Caustics Solver is kind of helping us with having the reflections be more realistic. So if I zoom in this area here, you can see that without the Fast Caustics Solver, we're getting some sort of a result. It's pretty nice, really, but it's not exactly what we want. Now with the new Fast Caustics Solver, you can see that we have a lot more detail in here. Take a look at this small pass here where there's a bit of a breakup in the reflective caustics. Now this is looking a lot more visually interesting than without the Fast Caustics Solver. Overall, you can also see that we have the reflections are a lot brighter, the reflective caustics are a lot brighter than with the version without the new Caustic Solver. So this is a bit of a, again, a bit of a night and day difference that we have here. Now trust me, reflective caustics are really fun and can make a huge difference in your scene. This example shows just a tiny fraction of how reflective caustics can create more detail in your image. I really encourage you to always keep reflective caustics in mind. Great, we're making tremendous progress here, and the next thing I want us to talk about is how caustics behave. If we go back to our pool scene, and this scene has a slightly different lighting than the one we viewed earlier, well, you can see that the caustics are showing up really well here. Vibrant, strong, and very clear. If I go into my lighting setup here, which again has changed a bit from the pool scene we've seen at the beginning of the video, you can see that it's just a default Corona sun and a default Corona sky. Now, if I change the sun size from the default of 1 to, for example, 32, you can see that the caustics will be barely visible now. Let's just give it a second to refresh here. And as you can see, the caustics are coming in, the pool is nicely lit, but the caustics are barely visible. Conversely, if I flat out disable the Corona sun here, well, now the caustics are pretty much gone. I mean, they're there, but visually you can't see a lot. You're probably wondering right now, well, how so? Well, for caustics to show up vibrant and strong in pretty much any scene, light size, light directionality, and light positioning matter a whole lot. An ideal scenario for generating nice, strong caustics is to have a bright source of light that is at least somewhat directional or focused. Ideally, you're also shooting a strong light source into a comparatively dim scene, because that will create fairly bright rays that will drive the caustics. Rest assured, this is all expected real-life-like behavior, and so if you were a photographer, these guidelines would have been equally important for you to consider. Now, do note that some scenes, like this glass scene from the beginning of the video, can have a lighting setup with a non-directional light or a strong directional light produce similar results. And that is because the nature of that scene and the materials involved allow for that. The pool scene, for example, though, that one is different and requires more thinking, just as it would in real life. Right, so now you're probably wondering, what about HDRIs then? Well, the situation is the same. This HDRI, for example, is very cloudy, so you can already see that if we were to use it in our pool scene, we wouldn't get a lot of visually interesting caustics effects going. The sun is behind the clouds, so it's very diffuse, which is comparative to a corona sun with a high size setting, or a corona light with a low directionality setting. Also, most of the sky is emitting light with similar power, so that's also not optimal to get visually interesting caustics going. Now, looking at this HDRI, you can see the difference. Now the strongest light source is the sun, which is comparatively small to the rest of the HDRI, which means it will produce a more directional light. So something similar to a corona sun with a low size value, or a corona light with a higher directionality value. Let's compare the two HDRIs in that pool scene. Well, oh boy, that's quite a difference indeed. Right, so what about a more mixed HDRI like this overcast one? Well, this one might give you a more mixed result, and you might actually want to consider matching a corona sun to the sun in the HDRI and then exclude the environment from that HDRI from generating caustics so that only the corona sun generates them. That way you get more control over the look of your caustics and you get a nice speed bump as the corona sun is quicker to sample. That being said, that setup is a bit more tedious. Great. Now, let's talk about artistic control a bit. The scene in front of us has a glass prism in the middle, and on each side of the prism we have a total of 4 lights. If I quickly bring up the interactive renderer, you can see how the scene looks like with the caustics enabled. Now, let's hypothetically say we only want one of these lights to generate caustics and not the rest. Okay, well, if I go into my light settings here, light properties, you can see that they have this generate caustics option down here. Now, if I disable it in all but one of my lights here, like this, you'll see that now only one light is generating caustics and not the rest. But do note, the lights are still clearly visible and they still illuminate the scene. They are just not generating any caustics anymore. So this can be used in a ton of different ways, really. If you're doing a caustics heavy scene and maybe want to have bigger control over which caustics you actually want to see, well, this is the functionality you'll want to use. Conversely, this functionality can also be used as a way to potentially optimize the performance of your scenes. Here is yet another simple prism scene to better illustrate what I mean. It's really straightforward. So basically we have 3 different lights. One is pointing directly into the prism with a very high directionality setting of 90%. The other one is a sphere, so basically a complete opposite of a directional light. And then we also have this light here, which has a fairly high directionality setting of 80%, but it's not really pointing at the prism. It kind of mostly shoots rays past it. Although due to the directionality setting not being 100%, some rays are going to still hit the prism, probably right about here, and generate some caustics. Right. So now, if we were to render this image for 5 minutes, this is the result we get. Take a look at the pass and ray amounts here. So we've got 24 passes and around 3.5 million rays per second. Now, because of the nature of the sphere light and the other one, this one that shoots past the prism, we could potentially do away with these two generating caustics and still get a fairly similar result visually. That's a theory. Let's test it out. So let's disable the ability of these two lights to generate caustics and check how the scene performs and looks like then. Right. So what I'll do is I'll select both of these lights like this, and I'm going to go under their options and untoggle generate caustics like this. All right. If we were to re-render now, this is the result that we'd get. Yeah. Now let's take a look at the visual differences between these two images, and let's also keep our eyes on the statistics a bit. Oh, and on the left, just so you know, on the left we have our before performance optimization scene, and on the right we have what I call our performance optimized scene, okay? Right, so let's pay attention to the visual differences between these two images. Here we go. Alrighty, so one is a lot more noisy, that much is clear, but the more noisier image actually has some extra effects in here that the performance optimized scene, the one that's less noisy, doesn't have. So if I zoom in, you can see that our before image actually has this nice caustic dispersion line forming here. It's really subtle, but it is there, and it isn't there in the performance optimized scene. This is a bit of a visual difference right there. And then also, I think I spotted a bit of a caustic line forming here. I hope you can see it. It's there in the before scene, but in the after, in the performance optimized scene, it isn't there anymore. It's very subtle, but it counts for something. I guess that's also how I would describe the general visual differences between these two images. They're not huge. They are there, but they're barely visible, right? Now, let's take a look at the performance here. So basically, our before image completed in the 5 minutes that it's limited to. It completed 24 passes, and on average, better yet, it averaged around 3.5 million rays per second. Now, for the so-called performance optimized scene, well, this one in the same 5 minutes completed 151 passes and averaged around 25.5 million rays per second. And so that is a huge difference that you can also see visually, because one is a lot more noisy and the other isn't. But there is that drawback of losing some extra details, visual details here, and obviously here and probably somewhere else in the image. But like I said, these are very subtle, so you can kind of do these so-called performance optimizations or not, depending on whether the visual differences outweigh the performance differences to you, or what you're going for in general. But do note, and this is very important, this scene is specifically designed so that we get a noticeable performance difference. We want it to exaggerate the difference so that we can more easily convey it. In a typical production scene, where caustics are not the only thing happening in the scene, performance savings will be less than this, but it will still be there. Talking about production scenes, let's switch over to one. You'll probably remember this bathroom from the Porter tutorial that we did. Turns out, this one is also great for some nice looking caustics. The light setup is pretty straightforward. We have our Corona sun in here with a fairly low size value, and then we also have our Corona sky in here with its default settings. Now, we do also have a couple of extra ceiling lights up here. There should be a total of 4, and if I browse through my object manager, you're going to see that, yep, here they are, 4 of them. Now, as for the lights themselves, you're going to see that these are basically your default Corona lights with a different radius settings, no directionality, and an intensity that works for this particular scene. So basically, these are just your normal non-directional Corona lights. Right, so right now, if I go into my render settings, under performance, you're going to see that we have the Fast Caustics Solver disabled. And if I open up my refractive materials in the scene, in the material editor, I have them all lined up here, you can see that under refraction, we have no refractive caustics enabled. Right, so basically the scene is set up to render without any noticeable caustics. And if we'd render this image out as it is set up right now, this is the result that we get. Looking good, but clearly missing some nice looking caustics. So what are we waiting for? Let's enable the Fast Caustics Solver here. First off, we can jump into the render settings and just enable the Fast Caustics Solver by clicking the Enable button. Right, let me minimize the render settings, and now what we also need to do is we need to select all of the materials again and enable the refractive caustics. And bam, we're done. This is how a rendered image with these settings looks like. And here is how it compares side by side to the non-caustics version. Pretty cool looking, yet super simple to set up, isn't it? Right, so now let's try to see if we can do something extra here. Let's try to gain some extra performance, because I think we could potentially do that without affecting the visual quality much. Extra performance is extra performance, am I right? First off, let me enable the Caustics Multipass. So I'm going to go under the Corona menu here, Multipass, and I'm going to enable the Multipass. Then I'm going to search for a pass type called Caustics. There we go. I'm just going to drag it in here. And also I'm going to open it up and hit Apply Denoising. There we go. So why do we want the Caustics pass in the first place? Well, I'll use it to better see what the caustics in my scene are doing. Because as we know, render passes are sometimes basically just isolated effects. Right, so great. With that enabled, let's take a look at how the caustics pass looks like. Okay, obviously we're getting some nice, good-looking caustics, basically all over the place. I mean, we saw that with the A and B comparison, and the difference really is quite noticeable, and this caustic pass really gives us a bit of a better idea of how exactly caustics are forming in our scene. So, I kind of think like these lights on top here are not really generating that many caustic effects. I mean, if you'll remember, they aren't directional or focused or just too strong. So looking at this pass, I'm just thinking maybe these don't do that much to the scene itself, caustics wise. Then, I'm also noticing some nicely blue tinted effect on the wall on the right here, and I'm just kind of guessing, but I think that might actually be coming from the environment lighting. So in our case, that's the Corona sky. It's subtle, maybe too subtle, and I think we could disable the environment from generating caustics, which probably in this case won't visually be that much different, but the performance might be even better. So let's do all that. First off, what I want to do is I want to tweak these ceiling lights to not generate any caustics. So to do that, I'm going to go into the Object Manager and just select all of these 4 lights, all of the ceiling lights basically, and I'm going to untick this Generate Caustics button. Now what we've done is we've essentially said, hey, these lights are not going to generate any caustics. And that was pretty easy to do. Now let's also do the same for the environment lighting. To do that, I'll go into the render settings, and under the Fast Caustics Solver menu here, I'm going to untick this Generate Caustics from Environment button. Now what that does is, it tells the solver to not take the environment lighting into the account when calculating caustics. What constitutes as environment lighting in our scene is actually just the Corona sky that we have here. Generally though, what constitutes as environment lighting is the Corona sky, obviously, but then also any HDRI lighting setup that you have in your scene, or the scene environment overrides from this tab here. Now do note that the Corona sun isn't considered an environment, and it has its own Generate Caustics button here, so it kind of behaves like the rest of the Corona lights. So that one is pretty important to remember. Now before we proceed, there's actually one more thing under the Performance Settings tab here that I want to talk about, and this is this Caustics Only and Caustics Pass button here. We aren't using it, but what it actually does is it just separates the caustics from the main beauty image into a separate pass. So the caustics are not going to show up in the beauty pass, they are just going to show up in a separate pass. And so then you can easily combine the two again in post-production and have, some extra control there. Right. So we've made some changes to the scene. So at this point, we'd normally hit render, but this scene is quite a tough scene to render because of its fairly small window openings. So we'll just quickly skip to the rendered images here. Okay, so on the left, you can see the image where all the lights and the environment are generating caustics. And on the right, you can see the image that we tried to optimize. Now, it does look visually different a bit, but I don't consider it to be too different. As you can see, all the major caustics are still visible here. So we still have all the effects we want to see and that are needed to give that extra edge to the realism, but we've also gained a little bit of performance too. Purely performance-wise, take a look at these stats. That is a fair bit of a difference there. Alright. So with all that said, this wraps up our caustics tutorial. We sincerely hope you've enjoyed it and that you've learned a lot. Caustics can be pretty cool, and so we wish you happy rendering, and we would encourage you that whenever you're lost or not sure what to do, come and visit our YouTube channel or visit the forums. See you around!